Solving quadratics by factoring is a three-step process. We follow the same three steps every time we go about doing this. The first step, we want to make sure that we set our quadratic equal to 0. So we have to get everything, all the terms, to one side, and then we can move from there. So I like to keep the leading coefficient on the n squared, this term right here, positive. So that means I'm going to move these guys over. So I'm going to move them both over with subtraction. When I do that, I end up having the quadratic n squared minus 3n minus 10 equals 0. So I've set it equal to 0. Step number 2, factor. We have lots of tools at our disposal. Factoring with a is 1, a is not 1, difference of squares, grouping, sum or difference of cubes, lots of things we could do. So what I need to identify right here is the fact that I'm going to use a equals 1. And the way these problems are set up, they're going to factor, but if we run into something later that doesn't, we'll have to use a different method. So when I factor him with a equals 1, I end up getting n minus 5 and n plus 2, two numbers that multiply to negative 10 and add to negative 3. And we're still set equal to 0. So we've set equal to 0, we factor, and then we use what I like to call the ZPP, zero product property, which is why we set it equal to 0 here in the first place, so we could use this property eventually. And remember, the zero product property says if two things are multiplied together and equal 0, then I can go ahead and split it apart and say that one of those two things has to equal 0. So this allows me to create these two little equations of n minus 5 equals 0 and n plus 2 equals 0. And those are just linear. They're pretty straightforward to solve. Here I just add 5 over, and n equals 5. And here I subtract 2, and n equals negative 2. And those are my two solutions to the quadratic. Remember, every quadratic has two solutions, two numbers or quantities that make it true. In this case, it's 5 and negative 2. If I go to a second example, a little bit more complicated, I still follow the exact same three steps. So, step 1, set equal to 0. Like I said before, I like to keep my x squared positive. So I'm going to move those over using addition, and I'm going to move those over using subtraction. So when I do that, and I combine like terms, I get 4x squareds on that side, and I get minus 14x, and the negative 8 just stays. And I set it equal to 0. I'm looking ahead to use the zero product property, which is why I set it equal to 0. Step 2, I go through and I factor. So I look here, and I could try a is not 1, but first I want to just yank a GCF out. So if I look at all those quantities, I can pull out a 2 and be left with 2x squared minus 7x minus 4 equals 0. It just makes my factoring easier if I pull out the GCF first. Now the GCF, let me explain a little about him. At this point, I could, if I wanted to, divide both sides by 2. And it would just essentially make that GCF go away. I don't like to do that. I just like to keep him the rest of the way, and then at the end I realize I don't really need him for zero product property. So just for completeness sake, I'm going to keep him there. And I'm going to factor this the rest of the way on the inside. I identify that this is a is not equal to 1. And I'm just going to give you what this factors into. We can factor with a is not 1 on our own. It's going to be x minus 4, and it's going to be 2x plus 1. That's the factored form of that trinomial there on the inside. So I did steps 1 and 2. I set equal to 0 and I factored. Now I have to use zero product property, which allows me to split it up and set each piece equal to 0. And again, I'm going to ignore him, my GCF out front, because he's just a number 2, and 2 is never going to equal 0. And like I said before, I could have just divided him away. So when I split this up into my two little equations, I get x minus 4 is 0, and 2x plus 1 is 0. Two simple little linear equations I need to solve. So this gives me x equals 4. He's one of my solutions. And this gives me x equals negative 1/2. And he's my other solution. So those are my two answers. I used the same three steps to get there. I just had to factor when a was not equal to 1. Now factoring is great if my trinomial factors. We're going to hit a lot of examples soon where my trinomial doesn't factor, so I don't get rational answers, and I have to use quadratic formula in order to get my answers.